Now let's look at a parallel configuration where the positives all stay together and the negatives all stay together. We'll use our combiners, our MC4 parallel combiners here. We will take the positive from each panel and plug them into the connector so that we take two connectors down to a single output. And then we take both of our negative connectors into this one to give one negative connection. And the output of that connection is what you would connect your wires going down to your input of your charge controller. So that's how you'd run that out. So with these in parallel, we should have a voltage that stays the same as a single panel, and our amperage should then double because we have two panels in parallel. And we're sitting 25.2 volts. So 25.2 volts is about the same as we were reading for a single panel. However, we have now doubled the maximum amperage that these two are putting out. So instead of 9.5, we're now at about 19 amps total coming down. So you need to consider that when picking a conductor size, your wiring going from your roof at your solar panel array down to the input of your charge controller needs to be able to handle that amperage. A couple things to note about these configurations, the pros and cons. There are a few to each type of setup, whether you go parallel, series, or a combination of both. There's some things you need to know. If you have them wired in parallel, when one panel is shaded and the other one's not shaded, the performance of one does not affect the performance of the other. If one panel is shaded, the rest still perform at their maximum level of output for your given conditions. That just about concludes the amount of information that you'll need to successfully wire up a single, double, triple panel, 6-panel system, whatever you're going to end up doing. You now have the tools and the know-how to be able to balance those numbers on the back of the sticker in accordance with the specifications for your charge controller.